Good morning. Welcome to our webinar this morning, Energy Efficiency Opportunities in the Construction Sector. Let me just get so I can operate the slide pack. 1 wee second. There we go. So just before we start, a quick reminder about the Carbon Trust. We're a not-for-profit organization. We are mission driven, and that mission is to accelerate the move to a sustainable and low carbon economy. We support that mission with under advice, footprinting and technology. With advice, we advise on the opportunities that are available in a future low carbon world. With the footprinting, we look at the environmental footprint of organizations, products and services. And we also help to deploy low carbon technologies and innovative solutions. So in terms of our agenda today, we're going to take a look at a typical construction site, although that definition alone is quite tricky, trying to explain what a typical construction site would look like. But we'll go on to look at where the opportunities for efficiency savings exist with regards to staff training, mobile plant, and the site accommodation. So to start off, just to kind of set the scene on what kind of expertise and knowledge that we have in the construction sector. We have done a lot of ESOS support work across the sector in terms of the main construction companies. You can see them outlined there, and also with regards to the ESOS audit experience. In terms of our split of our total ESOS work, there was almost 10% of that was in the construction sector. So we have had a wide exposure across the sector. So in terms of trying to define what a typical construction setting is, I think in context of this presentation, we're looking to focus on those settings where the construction company is going to be paying for the energy that they're using on site. Obviously, that incentivizes them to want to improve on that energy consumption. So we're probably looking at the phase 1 and the phase 2 sites. The other two, it tends to be where they are taking their power off another supplier, aren't paying for it, and therefore there isn't the incentive there to look to drive up efficiencies. Why would you bother to do it? Well, things are changing in the sector. I mean, in improving your energy efficiency, then you're going to be controlling your costs. So hopefully that will help to isolate you from the volatility of the price and inflationary pressures. That's the obvious one. That again then leads on to profitability, environmental performance in terms of shareholders, in terms of the general public, in terms of the people who are eventually going to be buying and living in the homes. It's they often want to see what environmental credentials there are. Compliance, of course, with the ESOS that has had a significant impact. And again, as we come around to ESOS phase 2, it could also be an aspect of the contract requirements, so that you're having to demonstrate your environmental performance as part of being considered at the tender process. So if we look at what a typical site energy split is, obviously the gas oil there is for the on-site mobile plant, which is over half of the energy consumption on the site. The natural gas is referring to mainly that's going to be in the drying out of the houses, and the electricity then, the majority of that is going to be on the on-site accommodation, and you can see how that breaks down then in the cost being split, the maximum being halfway between the gas oil and the electricity. So we begin to focus in then on the areas that we want to concentrate on. At a site level then, in terms of how that breaks down, the 20% for the actual plots, there's not an awful lot of opportunity there. I mean, the construction of a house uses a lot of water, and that water has to be dried out one way or the other. We haven't really focused in on what the most efficient way of doing that is, but it would be interesting to know if there's any innovations that you know of that are going on in that area. But as you can see, the vast majority of there is again is going to be used for the mobile plant. And what we're going to do is focus then on where the opportunities are on the site accommodation and compound, and then we'll look at the mobile plant as well in some detail. So in terms of that split down into actual consumption, it's clear there that the drying room is the largest consumer of the power on site, and then you've got the mortar silos as well. I think the details for that has come from two. It's a site that had two of the silos there. They run by 4 kilowatt electric motor. You know, if it's a busy site, these things are going to be running all day and every day. But the biggest, obviously, opportunity is lying in the drying room. In terms of what that looks like, I mean, you know, you're all going to be familiar with the kind of mobile plant that is on a typical site. Ordinarily, it's dominated by the telehandlers. In terms of the accommodation and compound, then you're looking at, as we've talked about, the silos, but you've got then the kitchen areas, the drying rooms. These are the compounds, and the accommodation is all electrical driven. So the majority of the comfort heating is all electrical, and again, then for the hot water, you're relying on the electricity for that as well. Plots and show homes, I mean, predominantly you're talking the provision of lighting, certainly in the show homes and the sale centres. One would hope that the vast majority of that is now going to be as LED lighting. But again, there's also the aspect of how do you dry out the homes as well. In terms of where the opportunities are to improve the energy efficiency in the sector, it's going to be driven through staff awareness and training. You're looking at the opportunities in improvements in the mobile plant and the opportunities in the on-site accommodation as well. So we're going to go on and look at those individually. I think from all our work across the sector, the conclusion is that the staff awareness and energy efficiency, even staff interest in it, is typically poor, and it's usually quite obvious if you spend any amount of time on the sites. You know, there's the heating's been leaving on, the lights have been leaving on. There's very little interest being paid, but I mean, it should be should become part of the culture of the workforce. I mean, there's a lot that can be done to improve the accountability, and in terms of driving up that interest in it's the staff need to understand that what's trying to be achieved, and in terms of then training as to how they can proactively and practically help to reduce the energy consumption. In terms of trying to then engage in a workforce, it's as simple as just driving up awareness. You know, get a start the poster campaign in the canteen, change the posters regularly. I mean, if you're leaving them up there for longer than 2 weeks, then you know they begin to just not be noticed. After a while, it also helps to try and engage the staff by asking their ideas. You know, how would they go about helping to improve the energy efficiency at the site. As I said, a big part of this is training. I think work we've looked at in terms of staff willingness to help an organization reduce its energy efficiency. There's a lot of willingness there, but the staff lack the knowledge and the skill to kind of take part in that process. But it's obvious with regards to training that it has to be ratified, obviously, from the senior management, as that gives it the authority with in the workforce. Training as the same as raising awareness. It has to happen on a continuous basis. You know, you can't just do it once and then forget about it for 3 years. It should become part of the weekly meeting. Should be a standing subject, you know, at the start of the week, and also not to overlook the subcontractors as well. If they have offices and stores on the compound, then obviously they should also be involved in it. In a simple kind of training tool, or even this can be also very effective at raising awareness, is a kind of a end of day or end of week checklist to go round to ensure that the likes of the time clocks are correctly set. If things should be turned off, they are turned off. And then other practical aspects of just site maintenance that are often overlooked and go unnoticed, where the door closures aren't working, or the doors are lying ajar because they've come out of alignment, and other things like that. So it doesn't have to be complicated. So in terms of, as we've discussed, the largest energy consumer is going to be the gas oil or the diesel for the mobile plant. This is a typical radar diagram of where the plant management would be at a typical site. Obviously, the wider the dark blue line, then the closer to best practice that a site would be. So that being typical, there is still some significant opportunity for improving the management of mobile plant. It should be seen as a controllable resource. It isn't, as you were, a necessary evil. It should be managed, and it can be managed. And certainly from the outset of a project, you're wanting to look at the process of the actual plant procurement in terms of looking to hone in on specifying the higher tier engines, which would have the incorporated eco mode with the auto idling and all of the reduced power modes. In terms of looking at life cycle costing of the plant, to ensure that over its lifetime, its running costs are as efficient as they can be. And really, the only way to ensure that those things are taken into account is to start to write those aspects into the actual procurement policies, which leads us nicely on. Obviously, it needs to be a written policy that is understood by the relevant staff, again agreed with the senior management, and should be regularly reviewed. Technologies are moving rapidly on, so you would certainly want them to be revisiting these things at least every couple of years. It also helps if there is a dedicated plant manager that can be at the site level or at the group level. It's want to be working with the local managers then to look to allocate a kind of responsibility for fuel consumption down to the individual site, so that there is that formal oversight of where and how fuel is being used. So some aspects then of looking how to reduce that fuel consumption. I mean, again, at the outset of organizing the site, the plant manager should have the role to ensure that the generator that they are hiring is appropriately sized. I mean, very often you go to whoever you hire the generator from, and they'll they'll usually give you the one that they have available, whether it's appropriately sized or not. If it's oversized, then it's obviously going to use more fuel than was necessary. So you need to try and get a handle on what the initial site loading is going to be to help you better specify that as well. The kind of the training aspect then is to ensure that the operators of the equipment understand what the best practice actually looks like. So you should work with the hire companies that understand what that is and try and incorporate that in the training. Also, obviously, the use of fuel is very dependent on the distance of travel. So there's work there to be done to plan how to operate the zones on the site to minimize the travel distance between the depots and the stores and the silos. Obviously, if it's a large site that's going to be there over a number of years, then you may well have to plan to move where the site accommodation is as well. Maintenance obviously plays a big part in the efficiency of the plant. Obviously, there are the mandatory maintenance checks that have to go on, but there are also the checks that the operator can carry out on a daily on a weekly basis that is going to impact on the efficiency of the plant. So you're talking about the likes of the tire pressure or how tight the track is, and often that kind of preventative maintenance will help drive up the efficiency. The other thing is all in terms of the movement of plant between sites. These very often the temptation is to just move it from one site directly to another, but best practice would obviously be sending it back to the depot to give it the once over, just to ensure that any ongoing or long-term faults can be rectified. Again, talking about the operator training, and it's probably going to be sufficient to latch that on to the wider health and safety training, but often you will have experienced operators of the plant who have been well trained, and it's I'm sure it would be best practice for them then to carry out the induction of the new operators and to pass on that best practice. In terms of then innovation, we touched on that again. Things are moving on quite quickly with regards to innovation in terms of electrification and the use of hybrid engines. But we're going to touch on that a little in the next few slides. So in terms of the opportunity, obviously, if you don't know how much fuel you're using and where you're using it, then it becomes impossible to manage it, as we've discussed. So, I mean, it would be best practice to go about a formal process of logging the fuel expenditure at each of the sites. This then allows you to focus in on the higher consuming sites in order to understand just why they are the higher consuming sites, and then being able to drill down into trying to understand the reasons for that. A lot of the modern plant allows the fuel consumption to be recorded, but also the operator behavior, and that can be a powerful tool in incentivizing how they operate the piece of plant. And if they realize that their fuel expenditure and their behavior is going to be monitored at a senior level, and as a result, some questions are going to be asked. And we'd looked at some vehicle software. I think we analysed it. This was for some ESOS work a couple of years ago, and looked at I think it was an excavator, in terms of how much of its operating time over the course of 30 days it was idling, and it became quite clear that the cost of that was substantial. So if you multiply that up across a number of sites and a number of individual pieces of equipment, then it can become very significant. Again, talking about the importance of operator training, we'd hinted that it's probably sufficient just to integrate that in with wider trainings such as health and safety, but it's the training shouldn't be done in isolation, a little like raising awareness, etc. You need to keep reinforcing the points. So it would be good practice to put together an operational best practice guide that can be communicated on a regular basis. Could even be stored on the piece of equipment as well. Typically, these kinds of operator training schemes would see a fairly decent reduction in fuel consumption with not a lot of effort. So when the new operators come in, you have a best practice guide that you can then run them through, let them have, and it's all of the kind of saving techniques that we've talked about in terms of the optimum placement of the plant with regards to the journey time. Talk about the regular checks that should be made, and also highlighting the optimal travel speeds and not operating the plant at 100% throttle. But all of those things could be incorporated into quite a short, quite a punchy training manual that can be used across the site. Again, we'd touched on the opportunity with regards to the innovation. There has been a lot of work looking at trying to move away from the reliance of the diesel engines to going to electric and hybrid drivetrains. A lot of work has been done, obviously, by Volvo on that. They look to completely electrify a quarry site. And they were looking at resultant cost savings of up to 25%. There's quite a good website on that. It would be worth having a quick look just to try and get a handle on where the opportunities are beginning to develop in the use of the on-site plant. So there's a basic case study there, just looking at the opportunities for the uptake of the hybrid technologies. The kind of fuel savings you could expect are in the regions of the 15 to 30%. Obviously, it's going to depend on how the machine is operated. There is an uplift in the capital cost between 9 to 10%, but as you can see, just in terms of the reduction in annual fuel cost at the bottom, the payback in terms of that uplift and the cost is well under a year and a half. So again, worth thinking about. It's why we would recommend the formalizing the procurement policy and making sure that that is reviewed on a regular basis, so that you can you're in a position to catch these opportunities quickly. So we'll go on and concentrate then on the site accommodation, look at the basic energy split. This is a result of a combination of a variety of energy audits across a number of typical site accommodations. So you're talking the office, the canteen, drying room, stores, and the toilets, and split out in terms of the lighting, heating, IT, the drying room again, and the catering. So that then highlights for us again where the main opportunities are in terms of the impact that can be made, and where we would want to focus our attention. And again, it goes around the drying room, but there's also opportunities with regards to the overall heating in the offices and the lighting. So that slide's highlighting what we would have typically seen in terms of the lighting. Usually incumbent would be fluorescent. Your option for improving that is to move to LED lighting. Typical paybacks 3 years, maybe a little bit more, depending on the run hours. Additional technologies that could be applied to improve that would be the use of passive infrared sensors, the PIR sensors. You would look at daylight dimming and the key override with a master switch, so that all the lighting can be switched off at the end of the day at the one position. What we did find is that the lux levels are often higher than what they should be. So your the accommodation are often overlit, and as a result, you're going to be paying for that. So a simple bit of lighting design work would reduce that. Also, in terms of the amount of natural daylight that come in from the windows, the incorporation of some daylight dimming would help to reduce that as well. Regardless, all kind of lighting controls should become should be checked on a regular basis to ensure that they continue to operate. You can see from the picture there the lux levels, and that was that's probably in the middle of the cabin. There was over 1,000 lux when when more than half of that would have sufficed. Space heating controls, you find that there are a variety of types being used, some better than others. Usually in the areas that we're talking about here would be the canteen and the offices. Again, typically a time clock. The option, of course, is because of the type of heating, it's usually electric convective, that it's in terms of its response time to begin to heat the space is fairly quick. So there is the opportunity to put these on to a PIR such that when somebody's actually in the space is when they will operate. And in terms of any issues with that kind of control, I mean, we can't think of any really. The good thing is that it does remove that requirement for the time clocks, which are often very difficult to work out how to program, and things go wrong with them and they can't be fixed. So the guys on site then just have to bypass it, and it's usually left on then. As a result, again, would encourage that these kind of controls are checked on a regular basis. Looking at the heating in the toilet blocks is usually electric convective. Again, it's on a time clock along with trace heating. The option again for that is to put them just onto either PIR or just a frost-stat. I mean, the heating in the toilet blocks are rarely used. So the option is to leave the incumbent heating in there, but to move the control just to a frost-stat. And then just looking at the water heating, the typical kind of over sink electric heating. That's an appropriate technology, rarely used at the best of time anyway, but they're fairly cheap, fairly robust, and will only heat the water that is required. So you do away with the likes of the standing losses and such like on other systems. And then just drilling down then into the white goods, just the incumbents, just we're assuming that would just be the normal basic option, where if you are going to be purchasing new equipment, then it's worth looking at the higher efficiency options, especially if the equipment's going to be there for a number of years or is going to get moved across a number of sites. And talked about the maintenance issue in the auto door closure, again, a common thing that you would see would be that these are inoperable or aren't functioning correctly. Obviously, the savings on the auto door closures would be reduced if the heating was on a PIR, but it's still a useful saving. And this relates to the doors to the offices are often left ajar because obviously the guys on site need to see who's signing in or who's coming into the offices, so they're jamming the doors open, which increases the heat load to the offices, whereby if they just had a clear panel in the door, then they would be able to leave them closed. So it's a very, very simple, very practical solution. So in terms of looking and specifying new accommodation equipment, in terms of where you have a window, or indeed do you have a window at all, I mean, often the way that the compounds are laid out can mean that the windows are either completely blocked, or they can't be opened. So there is an argument there for taking a bit more time in trying to plan out how the accommodation is laid out. But if the windows are going to be blocked, then if you're specifying new plan, then don't specify the windows, because they are an additional cost, and if you're not using them, then there's no point in having them. Looking at then the options for the drying rooms, you'll remember that this is the typically the largest energy consumer on the site. We looked at a variety of options. The typical equipment that you would have at the minute would be maybe a 2 to 3 kilowatt electric fan heater with a humidistat and an extract. Typically, what happens is that the humidistat isn't working, therefore the extract fan doesn't come on. The room's overly humid, which impacts on the rate of drying. I mean, I think in all of the ones that we were in, they're typically aren't fit for purpose. The improvement options is obviously to improve the rack arrangement, move them from the outside into a central rack. Your options could be storage heaters. Problem is you can't predict with those. The drying hangers, this would be equipment you would see on oil rigs and the likes of the fire service, where they actually blow warmer on the hanger, so that it introduces the warmer into the middle of the clothes. They're very good, but they're also very expensive. Your other option is then to go for a heat pump, which is a very efficient way of providing heat. There are the option then is to go for a humidifier, but the problem with that is for the humidifier to work effectively, you still have to add heat into the space to get the process of evaporation actually going. So we looked at options then, just to do some cost sensitivity analysis on replacing the electric heating in, well, actually all areas, but being specific to the drying room. That's to replace the convective with an air source heat pump. You're typically talking about maybe a 2.5 kilowatt thermal heat pump, which would provide an equivalent to the incumbent heating. Obviously, it's very dependent on the annual run hours of the accommodation space, but certainly with regards to the drying room, in terms of the longer run hours, it does make a quite attractive alternative to the current drying system. Also looked at the options. Do you put in double glazing or do you not put in double glazing? We did the same cost sensitivity analysis for the office areas and the canteen. And we compared obviously the heat loss and the reduction thereof from single glazing, then moving up to the UPVC. Again, very dependent on the run hours, but in those areas that we did examine, which is the office and the canteen, there's still quite a good argument in if you are specifying that you ask for the double glazing to be included in that, in terms of the payback from the additional cost of the rental or the purchase. Also looked at increasing the insulation from an incumbent 50 mil to 100 mil. Again, even with the extended run hours, with the exception of the drying room, it doesn't stack up to want to double that. And just in terms of how often the space is heated, the incumbent 50 millimeters is plenty. And then looked at what the financials would look like just to install some solar PV, just to give the site its own the option to generate its own energy. So we did it looking at the area available of a standard unit. It's in the region of 30 meters squared, and that the 100% of the power that would be generated would be used on site, and that's highly likely. So you're looking at a payback of 7 to 8 years based on 12 pence per kilowatt. So if the unit cost rises, then obviously that has a significant impact. And also, if you consider that you may well be offsetting the cost of power from a generator, then it really does begin to make sense. There are going to be a few problems with regards to keeping them clean, so you may have to build in a bit of time for someone to turn a hose on them every once in a while, but it's well worth considering. So we'll have a look at some of the audit pictures that we would have taken. This is of the office accommodation. It's sitting above a store. This is in central London. So you can see it's an older container. It's had a bit of wear and tear. You can see where we've turned the thermal camera on it, where the impact of the damage on the outside is impacted on the insulation, and has rendered quite a bit of it useless. I'd suggest probably that It's a result of the insulating getting wet. We talked about the impact of double glazing over single glazing. You can see in this picture the high heat loss. So the thermal camera is picking up a temperature in the glass of 14 degrees, which is obviously coming from the higher temperature in the inside. And if you compare that with the picture there of site accommodation that has been double glazed, the improvement or the reduction in the heat loss is quite stark. Also, this was the same site in London. They had the heater in the women's toilet was running. It just had been left on. There were no women working on the site, so the site manager was of the opinion that had probably been running for a number of months as well. And this was from this was a refurbishment. I think it was a large block of flats, and this was the site accommodation at the base. You can see where the old lighting in the roofing void has been covered over by the suspended ceiling. That lighting had been running for God knows how long. It had been on. Nobody knew where the circuit was. There wasn't a switch. And then the picture on the right is just to highlight areas that aren't been used. Then the use of a PIR would help to improve the efficiency there dramatically. Onto the use of the timers for the heating. They tend to be these small kind of controls that are very, very hard to understand, very hard to change, and as a result, they just become bypassed and left on. Again, the use of a simple PIR to control the heating in these spaces would be of use. And just looking at the other spaces you'd come across, top left, you're in the canteen, nobody there, lights are on, heating's on. Again, reference to that fan heater in the ladies' toilet being left on, and then kind of the parasitic loads that can introduce themselves into site. You know, the site managers, he's brought on a little fridge with a lighting on. He has the milk in there, and it's going to be running there all day, every day when he isn't there. You know, it would be quite safe to get that to switch off. Again, that can be easily facilitated with the use of a centralized master switch. So just in terms of what the Carbon Trust has to offer in terms of support, we've got our Green Business Fund services, where we offer out free energy audits to SMEs, and these can, depending on the site energy use, these can be either remotely or can entail a site visit. There's also the virtual energy manager, where you would get all the services and the benefits of an on-site energy manager, but without having the cost of employing one. Kinds of how that service would look like. Obviously, it's a standard energy management process of setting out the policy, getting a strategic plan, looking at the information, improving the quality of that information, then going into the setting of reduction targets, engaging with employees, staff training, and then developing a route map to allow the organization then to be able to take that forward on their own. We also offer implementation advice, which is up to 5 days support, where we would do a feasibility check of the project you were looking to do. We would write out the specification. We would carry out the tender process for you, help you to identify suitable suppliers from our green business directory. And there's also then the capital contribution. A word of warning, though, that the capital contribution is close to coming to an end. So if you have projects that you're wanting to avail of this help, then you need to be getting on with it. But the capital contribution is offering up to £5,000 towards the capital cost of the purchase and installation of energy efficient equipment. Obviously, the expected savings would need to exceed the project cost in less than 5 years. We've also got a number of workshops based on improving energy efficiency training. They are taking place around the country, and the ones upcoming you see are listed there. It's well worth going to. They are very, very informative. So in terms of the capital contribution, then it's up to 15% of the project capital costs, up to a maximum of £5,000. Again, these are not going to be on offer forever. If you have a project, again, then you need to be getting in contact with us. We also have the Green Business Directory of accredited suppliers. We have put the suppliers through a rigorous process of looking at their financial stability, looking at aspects of their management, complaint handling, staff training. So we've gone through a good process, good robust process of kicking the tires on these. We ask for we ask for case studies from them, and we will contact the organizations that are represented in the case studies and then ask about the performance, how satisfied they were. So it's a body of suppliers then that are accredited and are accredited across a wide range of technologies and geographic areas. It's well worth then having a list, or it's well worth having a look at the list if you have a project in mind. The processes of applying for any of those services is very straightforward. It's online or by phone, and you've got the website there to look at. Eligibility, England, Scotland, Wales only. Again, limited to SMEs. And includes schools and charities, and you've got the criteria there of SME. If you're in Wales, lucky you. You've also got the option of the Carbon Trust interest-free energy efficiency loans, which are offering up to £200,000 interest-free, and based on £1,000 for every 1 tonne of CO2 saved by the project. The repayments are typically over 1 to 4 years. That's going to be based on the payback of the project, and there are some eligibility criteria as well there that have to be met, but it's certainly not onerous, and it's a very, very successful scheme. Are there any questions? So that's the end of the presentation. If there are any questions, I think we're going to get them read out.
We've just got one quick question here. Could you explain what PIR stands for?
Yeah, I think I did. It's passive infrared sensor. So all it means is that when somebody walks into a room, it triggers the sensor, and then it will it can bring the lighting on or the heating on, depending on the layout. Is there anything else?
We'll just give it one more minute to see if anyone else has any questions.
No problem, thank you.
Right, so I think that's all the questions for today. So thanks, Danik, and thank you everyone for attending. We will be sending out the slides after the webinar, and that will be probably in the next 24 to 48 hours. So thank you everyone, and have a great day.